All right. So, sorry. Okay. So we are going to apply calculus to parametric problems. So the first thing is here's an example. If we have parametric equation, x of t is equal to t squared plus 1, and y of t is equal to t cubed minus 4t. Find the equation of the tangent line at t equal to 3. So when we find the equation of a tangent line, what do we need? We need the slope at the point of tangency, and we need the point at the point of tangency. So first, let's do slope. Slope is dy dx. Now, what we're going to first do in order to get dy dx is we need to first find dy dt and dx dt. So dy dt is the derivative of this expression, and dx dt is the derivative of this expression. So for dy dt, we get 3t squared minus 4, and dx dt is 2t. So now I want to find what we usually have as our derivative, which is dy dx. So dy dx is the same thing as dy dt divided by dx dt. And now we're going to evaluate it at t equal to 3. So all we do is we take each derivative and evaluate it at t equal to 3. And so then I show how I substituted 3 in for each of my t's, and we get the slope of the tangent at t equal to 3 is 23 over 6. So now, what is the point of tangency? Well, if t is equal to 3, we're going to take 3 and substitute it in for t to get my x coordinate in x of t, and we get 10. And put 3 in for t here, and we're going to get our y coordinate is 15. So our point of tangency, when t is equal to 3, is 10, 15. So what is the equation of our tangent line? Y minus 15 is equal to 23 over 6, that's supposed to be 6, x minus 10. That is the equation of our tangent line. Now, part B is find the points where the tangent is horizontal. So where is the tangent horizontal? The tangent is horizontal when the derivative is equal to 0. So when is the derivative equal to 0? That is when the numerator is equal to 0. What represents the numerator in the parametric equations? dy dt, just like what we had up here. So we're going to set that equal to 0. So I'm going to take my dy dt expression and substitute dy dt with 0 and solve for t. And then I get t is equal to plus or minus 2 over square root of 3. And then what you do is you substitute those values in to get your coordinates. So when it's positive, this is my coordinates, my x and y coordinates. And when it's negative, this is my x and y coordinates. That's the answer to part B. Now the next example, this one is just about, finding the slope and equation of tangent line. And then now we're going to apply derivatives to finding the maximum height of a particle. So what is the max height of a particle whose path has parametric equations? X of t is equal to t to the 9th power, and y of t is equal to 4 minus t squared. So when we think about finding the maximum height, what do we generally do? We take the derivative and find the critical numbers. So if I take the derivative just like we did before, the derivative of y with respect to t is negative 2t. And the derivative of x with respect to t is 9t to the 8th power. Then we want to find the critical numbers. What are the critical numbers? Before we do that, find dy dx. And that is going to be this negative 2t divided by 9t to the 8th power. And when you reduce that,
Stacy Ramsdell, can you please call extension 2051? Miss Ramsdell, 2051.
sorry. Okay, when you reduce that, it ends up being negative 2 over 9t to the 7th. So, as I was saying, how do you find critical numbers? When your derivative equals 0 or does not exist. Well, if I look at my derivative here, there is no way for it to equal 0 because the numerator is negative 2. That is always going to be negative 2. So the only situation I have is does not exist. And when is that going to occur? When t is equal to 0. Therefore, t equal to 0, whatever our t equal to 0 is, that is our critical number. So how do you find the maximum? That is when dy dx changes from positive to negative. So we generally do a number line. So let me do a number line. Dy dx. Now, my first critical number does not exist, and that is when t is equal to 0. But generally when we did number lines, these were all x values. These represented x values here. So when t is equal to 0, what is my x coordinate? That is 0. X is equal to 0. So now I want to go to the right and find out what is my sign on the right. So I'm going to go, okay, here's 0. So give me a value that's on the right. X equal to 1. Now I want to find out what is the derivative when x equals 1. So I want to do dy dx when x is equal to 1. Well, I need to know what t is because my dy dx is in terms of t. So when x is 1, what is t? Well, since x is t to the 9th, then that's easy. T must be 1. So I'm going to say this is when t is equal to 1, which is the same thing in this situation as x being 1. So let's find out what that is. That is negative 2 divided by 9, negative 1 to the 7th power. And so when we do that, not negative 1, positive 1 to the 7th power. So when we do that, this is going to be negative 2 over 9, which is a negative. So now let's find out what happens when you go to the left of this. So if I go to the left, let's say x equal to negative 1. These ones, negative 1, positive 1, seem to be easy to work with. If x is negative 1, then that means that negative 1 is equal to t to the 9th. So what does t have to be? T has to be then negative 1 if I 9th root it. So t is equal to negative 1. So now let's find out what is the value of the derivative when t is equal to negative 1. So negative 2 divided by 9 times negative 1 to the 7th power. And that is going to end up being a positive. So this is positive. So my derivative changed from positive to negative. Therefore, this is going to be the relative maximum. So now the question was, what is the maximum height? Well, the maximum height then must be the y-coordinate. Since max occurs when t is equal to 0, then max height is y of 0, which, what is y of 0? 4 minus 0 squared. So y of 0 is equal to 4. So max height is 4. And that's the answer to that question.